So I'm gonna let this run down. It charges a little bit faster with this coil right here, but it's not fast enough to compensate for being spent. So that needs a little bit of tweaking. It's alright though. This is the rate at what we're spending from the cat bank. Alright. So I had this idea that I would tie the trifilar output, the red strand here, and this coil's output through the cat bank to another cat bank which is larger. Is for storage, and that's what's draining right now is the big one. And then through the battery, which was suggested that I do to constantly chemically change everything from, you know, the electrolyte to the lead acid. And over here we have raw electric, copper to copper. And this is it's pretty cool. I think I'm going to let it run down a little bit, and then I'm going to probably hook up this wheel, this motor over here. I originally had this coil, which is a 13,000 turn 32 gauge coil, hooked up on this wheel, but since it's a secondary wheel, there was a lot of lens effect, but it did generate up to about 25 volts of AC, which unfortunately was not enough. But that was pretty impressive. The secondary wheel was generating like 25 volts, man. That was great.
No doubt. Thank you for the like. Welcome to the channel. Drop a comment if you have any questions. We're working with pulse motors today.
The cat bank is slowly dwindling.
There's the measurement on that. And then there's the cat bank.
It's a 500,000 microfarad cat bank and 16.2 volts.
Thank you for the likes. Welcome to the channel.
Thank you, thank you.
Drop us a comment if you have any questions about the build.
So what's happening is we're gathering from the trifilar strand, which is transformer like strand. So it's wrapped up in the coil that's got the drive strand in it. So you get some residual effect from the drive strand on the trifilar strand automatically. Just for turning it on, you get power. And then, of course, with the rotation, you get more power from each magnet that passes. It is additional power to the power you get from the transformer. And then this is 100% just there to generate AC electricity. And then you put both forms of AC into this cat bank, and it gets scrubbed, and it comes out the other end DC that you can use. Of course, you can use AC with a pulse motor. It's not really an issue, but I consider DC to be a much more clean method of doing things. I haven't really used AC with the raw electric, and I want to do that. Got my Variac over there. I'm going to try that out. Now there's things we can do to improve the performance of this system. One is I could swap this coil with the coil that's across from it, the red coil, and that would lessen the cost because the red coil is bigger and it has thinner gauge wire in it. So that automatically is going to lower the cost. And we might get pretty similar, not the same output. There's not going to be the same amount of torque. There's not going to be the same amount of a lot of things, but we might get comparable output for generation, electricity generation.
Hey everybody, welcome to the channel. Drop
Hey.
a like and subscribe. Let us know if you have any questions.
Yeah, hit the join button. Heck yeah. Come over here and tell me what to do.
Right
All
on.
All right, here we go. See, that's even giving me ideas right now. I could swap that coil for this coil, and I could increase, since there's no resistance on this side whatsoever, I could put some resistance in it via a coil. Just trying to see here. Like this coil right here it's a resistor. That's why it's there. This one and this one right here.
And coming at it there.
Oh yeah.
And we're draining it, so the slower it gets, the slower it gets.
Yep, the less voltage in the cap bank, the slower the motor goes. All right. So I am going to, now that this is depleted and we know that something's not right. I mean, the objective here is an over unity state. That's the objective. That's what was suggested would happen. I didn't necessarily believe that, but it's only half of what he suggested that I do. It's only what I have. I didn't have everything that he suggested that I have. But in its current state, definitely not even close to unity. But this battery right here is a dead battery, and I just ran that motor off of this battery, but the cap bank was connected to the battery as well. So I'm actually running it off the cap bank through the battery, which is that extra chemical interaction.
Hi everybody, welcome to the channel.
Hello.
Thanks for dropping in.
Right. I'm going to hook up this other cap bank and we're going to get the other motor running real fast. Senor, here we go. All right. I want to disconnect all this stuff because I don't want any kind of residual going on right now. You know, actually, I believe this can stay on the cap bank. And we'll just monitor. I'm pretty sure that nothing is really going to be going in there because it's just this coil that's hooked up right now. And I don't think that, my hypothesis is that that's nothing by itself.
Hey everybody, welcome to the channel. Drop us a like, subscribe if you like this kind of content. We're working with pulse motors today. and from a stored input, not a direct one. And now we're working with direct.
Yeah, I hooked the Eve distribution back up. We're turning on the power now.
All right, so yeah, go back to the first 10 minutes to get the stored one.
Yeah, it's dead. I'm not gonna. It's
Well,
dead.
we drained it. Yeah,
Okay.
that's pretty much what we did there. Yeah. Hear the hum.
There we go.
These are pulse motors.
This right here is as simple as it gets. You got your coil, you got your power supply, which is the output of the other motor, and you got your switch, and you got your rotor, and that's it. And that's as simple as it gets. Awesome. And that'll get going after a little minute. It'll be going pretty fast.
Welcome in, everybody. Let's see if we can get it up to 10 likes. Thank you for the likes so far. Appreciate it.
Thank you, thank you.
We had a little bit of discussion about over Unity earlier. I mean, it's a holy grail kind of goal.
I wouldn't necessarily consider it a goal unless you want to pull all your hair out.
Right. Yeah.
I would consider it like an Easter egg.
Mm. Thank you for the like.
That's just my opinion, man. I don't really believe in fairy tales. I mean, if it's scientifically, then it can be scientifically explained. If it's a scientific thing.
I saw Meg.
Uh,
Yeah, the shark movie.
oh, it's going up. Oh, it's going up pretty fast. Oh,
And then it's just stabilized when I got it on there. All right, 2.9.
there it goes. Yeah, it's only about 20 seconds. There's like no power going in there. That's awesome. The 20-second tick is not bad for just that coil. Remember, that's 500,000 micro. It's a big capacitor right there.
Oh,
What's up?
motionless electromagnetic generator.
Yeah, yeah.
Meg. Yeah.
Yeah, I've seen a Meg. I've heard about the Meg. Yeah, the Meg. But this is motion, not motionless. And I've done some motionless generator stuff myself, and it is awesome. But I would never do somebody else's thing. I can't say that. I can't say that. If it's good and I like it, I will do it. I never found the Meg that interesting.
Welcome in, everybody. Let's see if we can get it up to 10 likes. Thank you for dropping in. Let us know if you have any questions.
But I've seen it do some awesome things. So me personally, I just never found it that interesting.
Do you think you could power a complete house with this if you upscale it?
Yeah. And it's not about necessarily the upscale. Wouldn't have to upscale that much. It's how you transform the energy throughout the system. So, I mean, you're going to have a base in, which will probably be, how much is it? 57 watts or something?
Well, yeah, you got your fridge, you got any computer, you know, anything that's got.
Well, definitely a
Vampire
mini
power.
house. Definitely one of those small houses. Could be powered by one of these. A little bit upscaled. You know, it could do lights. In order to do, it can't do things that require a bunch of amps. It can't. The conversion rate wouldn't make sense.
Did you have any Bendini?
Yeah, over on that side right there is SSG Bendini. The circuit.
The circuit.
From K Energy Store, if you could zoom in on that one, bro. Yeah, thank you. That's from K Energy Store. Hit them up, man. Get yourself one. Those are awesome. This on the other side over here, however, is not Bendini. This is definitely not Bendini. This is old school, simple circuit, man. This is, like I said, as easy as it gets. You got your switch, you got your coil, you got your rotor, and currently the power supply is the other motor. Its output is running this through this cap bank right here in the middle of it too. Currently though, with the 9 magnet rotor, we are pulling about an amp. So I don't think you could run the 9 magnet rotor in and over unity.
So there's no batteries in this setup. It's directly from the power supply at this time.
Yeah, I'm charging up the cap bank right now to run a dead battery. You know what? I'm going to change the rotor to the rotor that I'll probably be using. It's a little bit louder because it's lighter. It's thrown around a little bit more, but it's a 2 magnet rotor. It's really nice. I love how that big one's got a flywheel effect.
Because you cut off the juice a while ago.
Yeah.
But again, it's part of a closed system, so it's always going to go slower unless there's an input.
That's right. There's a lot of speculation and hypothesis as to what would happen if that theory was broken. And so most people think that theory hasn't been broken yet because of those hypotheses. Alright, so our amp draw is down to 0.5 now from 0.9. We are probably generating a lot less magnetic induction electricity. The electricity we get from lens effect is a lot less because we only have 2 magnets instead of 9.
Hey everybody, thanks for dropping in. I see we got 6 likes now. Let's see if we can get that up to 10.
Yeah.
Subscribe if you like this kind of content. Let us know if you have any questions.
So I like the 2 magnet rotor. It's nice and fast. You can set up a relay with it, 120 or 180 and a 90 degrees. So if I have a drive coil here and a drive coil here, I can set up a relay with the 180 magnets, and it will, I don't need any relay switching. It switches automatically. Mike does, man. He told me about that one.
Peace, SAQ. Thanks for dropping in.
Peace, man.
Peace, Nick. Thanks. Peace, Neek. Thanks for dropping in. I need glasses. Mike is here.
What's up, Mike? I'm gonna go get my water real quick. I'll be right back.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe, leave us a comment. Let us know if you have any questions or if you want us to test anything out. Oh, my bad, SAQ. I'm Christopher, and the experimenter is Papa Bale.
All right. So
There is external input right here. Power supply.
yeah, we'd never try and hide it. There's no
Yeah.
motors under the table. There's none of that crap going on here.
Mike's like, you like the 180 rotor mag and 90-degree drive coil config.
Well, sometimes it's worked for me once out of 3 times. There's always a big voltage drop on one of the batteries, so I'm thinking I gotta get it going before I hook it all up. That's what I think. Because as soon as I clip that last clip, man, we get a short and everything starts smoking. So it's gotta be moving before I clip that last clip.
All right, everybody, we need one more like to get it up to 10 likes. Let's do
One
this.
more,
We
let's do
appreciate y'all.
Let's do it.
Thank you so much.
Woo! All right. And I mean, even with the less amperage out, or in, we'll call this in, we're still getting magnificent output. Compared to the 9 and 9, the 2 and 4 is almost the same in regards to the second motor.
Are you using double pole switching when you do the 180, 90?
Nah, well, I don't understand. All I do is hook it up. I put the coil here, the coil there. I hook everything up. But when it's not on, and you just connect it, I don't know what it was. It could have been that one of the transistors was bad. That could have been one of the issues, or the main issue. But, I mean, both times, I just clipped it, the last clip, to like put the input with the output of vice versa coils, and smoke. But the first time when I spun it, before I clipped it, it was already on before I actually clipped the last clip. Is the only time that it actually worked.
Okay, to avoid the short, it needs double pole switching.
But Mike, I got it to work without the double pole switching.
That one out of 3.
Yeah, I just got done explaining that.
Well, he might have.
It was you. It's all right.
Yeah. Yeah, he's like, you can, yes, yep. So no, like I don't know when the timing is. I just
Yeah,
read them
it's
when I see
definitely a
them.
lag issue. It's all right though because
Depends on the circuit. Yep.
oh, let me think. What circuit was I using? Oh yeah, it was one of my like one of these, just one of these ones right here with no resistances. Oh no, it wasn't. Not that time. It was actually this one. You can still see the wires. The output from the output and the input from the input are fried. They shorted out. It might be because I hooked it up wrong. I could have definitely hooked it up wrong.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like. Let's see if we can get it up to 15. We appreciate y'all.
Let's do it.
Drop some comments if you got any questions about the build.
So I was just thinking about some permanent magnet builds. What would you guys use to yoke a permanent magnet on this setup? Okay, let's just narrow it down to this table right here. What would you use to yoke permanent magnets? Let me get my stack real quick. Alright, like these right here, we'll split them in half. And like this stack would go here and it's pulling. And this stack would go here and it's pushing. So and then you start it up, right? But you don't want like the side energy, the energy that's coming off the side, to clip the opposite pole as it's flowing past, right? So how would you yoke these so that you only have the pole and everything else is covered up?
It's like a Y. It would be like a Y, like a slingshot holder. I don't know though. Any suggestions?
I was thinking
Connect
of,
an iron bar between them.
I was thinking aluminum wire. Wrap them in aluminum wire. You might not know what I mean by yoke. What I mean by yoke is to block the magnetic field. So it's got to be a metal that will block the magnetic field. And I think aluminum would do just fine.
Brass or aluminum will block.
Brass or aluminum. Okay. So I got aluminum.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe, let us know if you have any comments.
So there's some aluminum wire. Like if I wrap it around this thick enough, I should be able to block it, right?
I think that's right.
So that's an idea, and I'll try that. This is awesome because this is only half of the normal system's input. The SSG is a 12 volt system. This is 6.8 volts. Of course, you can run SSG on 6.8 volts. And I'm turning it up a little bit because we got room to wiggle with the amperage. Do a 9 volt battery. It's a nice even number.
You can see the arc.
So currently both of these coils are hooked up as resistors to lessen the heat in the arc for the switch. And without, trust me, without these two coils, that wouldn't be running the way it is. It'd be like sticking and very hot. It'd be very hot.
Hey everybody, welcome in. Thanks for dropping by. I'm showing 12 likes right now. Let's see if we can get it up to 20. We appreciate y'all.
Thank you, thank you.
There's 100 of you guys here right now, so we appreciate you guys dropping in.
Thank you. Thank you for stopping by. I'm looking at pulse motors right now.
Peace, Mike.
Peace, Mike.
The wire probably won't work. I think displacing the S side field, south side field, with an iron bar might work better.
I hear what you're saying by displacement. Yeah, I could give it a shot. I might have a piece of iron laying around.
How's it going, Matthew? Welcome in. Thanks for the comments.
Hey, hey. Alright. This is like a 9-volt battery right here. Doing all this. It is the output of the power supply, but it's only at 9 volts. It's at a steady 600 milliamps though, so I don't know many batteries that can do that. Awesome. Alright, so what I do want to point out is that the trifilar strand that is hooked to that cap bank in the middle, see how those lights are really red? It means there's a lot of excess energy that isn't being used by this motor. And it's being stored in that cap bank currently. But if I were to stop the input, which is coming in from these two right here, those lights would dim out in a heartbeat. But currently there's more energy going in there than is being used by the motor, which is good. And I got another one of those over here, and it's hooked up to this coil right here, but you know, it's hooked up to the cap bank for its output, and this thing is basically a bottomless pit when it comes to energy. I mean, that's not necessarily true, but it takes forever. It just, these lights are never going to light up because the bottom of the reservoir is, you know, higher than the buoy is to light the light. Kind of, it's lower. So as soon as it gets up, you know what I'm trying to say, right?
Yeah, like
The flow through is to the point where there's no buildup in the cap banks. These caps don't fill up because these ones are so big and they're not filling up fast. But there is a large amount of energy flowing through the system. You just can't see it through the indicator lights. You can see it on the meter though. We're already up past 3.5. Awesome. Yep, just changed 6.8.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe, let us know if you have any questions. This is Papa Bale.
Hey, how's it going?
How's it going, Time and Tide? Welcome in.
So I think this is the best rotor for the motor. The 2-magnet deal is definitely, we're probably getting the most speed out of that one too. Definitely getting the most output here That's awesome. But we are putting, with the other ones, we can't put in more voltage because the amperage is already so high, down at 6 volts. But see, as you can see, we're up 9 volts and we're at 600 milliamps. That's awesome. Of course, with the SSG and the resistances in the SSG, you can go up to 12 volts, no problem. 300 milliamps, 12 volts. And that means that the power that's coming out through the output is around 12 volts, which is awesome. Right here, I can guarantee a little less than half of that. I'd say it's right around 5.75, maybe 6 volts. Then we'll come up on the multimeter. Let me, reiterate that. It's voltage that I can read, and I don't know if the reading is accurate. So, but it is what the meter says, and I haven't jerry-rigged it or anything like that. So.
That's so cool. You were talking and time to ask a question, and you answered it as you were talking. That's great.
Awesome, yeah. Because, if I try to explain a lot of stuff that I do because, one, somebody might not know. Two, somebody might think something that isn't true. And I just want to, say right off the bat, man, this stuff is real. I haven't done any over unity yet. There's no over unity. I haven't reached unity or anything like that. But the motor itself, freaking awesome. How you use it, how you run it, awesome. Of course, I don't know. I've attempted a few circuits, over unity circuits. I don't know if I'm doing it right. I got a cat bank, I got a dead battery, and I got a coil. And I think that's what I need. I might need, but 2 cat banks, 2 coils, and then 1 route for all that energy to take. So I think I've only got half of what I actually need to run that one circuit. I don't know what the circuit's called. But the battery is just functioning as a conduit. The energy from the cat bank goes through the battery so that the battery can change it yet again. The motor will run off the cat bank or the battery. It'll run off of either one, not this battery, but one of those batteries. It'll run off of, either one. But this battery over here needs the cat bank to actually function at all. So, hey. So cool. And then what I can do is I can take these clips, stop this motor altogether, clip them to this cat bank, and this will charge 5 times faster than it's charging right now. And these lights still won't go on. They'll be a little bit brighter, but they'll not be as bright as that one over there. But I like that one. I like this big one. When it spins, it's got that double spiral on it, so I like it. I like to draw things on them. You got an outward spiral, and you got an inward spiral too. So it's got both of them on there.
Pulse motors and art. That's a nice convergence there. Welcome to the channel, everybody. I see we have 70 people watching right now. Let's see if we can get the likes up to 20. We appreciate y'all so much for liking. Subscribe if you like this kind of content, and let us know if you have any questions.
Right. Huh. I'm wondering here. I think I'm gonna try and You all right?
I don't know, man.
I'll back it on. All right. I'll have to stop it. Yeah, I'm gonna get, since the red coil is a tri-filer coil too, I'm gonna see if I can't get its energy in on the game here. And it's a parallel connection to this one. It's run through the SSG. Should I go output or tri-filer? I think I'm gonna go tri-filer. Alright, almost there. There it is. We'll get the light output. I think it's going faster. But like the lights aren't lit up anymore. They're a little bit, but not really. Yeah, just a little bit quicker. Seven five. Oh yeah.
Hey, Mr. Nice, we're working with pulse motors today.
Hello, hello.
Welcome in.
Alright. Alright, so I'm going to explain the circuit real quick. We've got our input from the power supply, and it's going through this transistor right here, which is hooked up with the 123 circuit. You have a nice little halogen bulb right here, connecting your emitter and collector, and that goes on to this coil, which is a trifilar coil. You got a 32 gauge trigger strand and a 20 gauge trifilar and an 18 gauge drive coil. Alright, so the energy from here gets outputted two ways. One through the collector, and I'm not using that way right now, and two through the trifilar strand, which is hooked up to the cap bank in the middle here. Alright, from there, the energy goes to this simple circuit right here. You got your coil, you got your switch, you got your rotor, and then you got your resistance coils over here, which are added. This is a little bit more advanced. You don't need these. Oh, this one does need it, but you know, they're not essential to run the circuit. And then the power supply, which is of course the camp bank in the middle, which is being powered by the trifilar strand. Okay, now we have a cap bank right here, and it's being charged by the magnetic induction of this coil. AC electricity is being generated and transferred into this cap bank, which is then transferred into the cap bank. But this changes it from AC to DC. It's got 4 bridge rectifiers in it. It's got AC caps, DC caps. It's an awesome little mechanism. Alright, and on the other side, we've got 20 gauge coil, 22 gauge trifilar, and a 30 gauge trigger. We got 730 turns of all that, so that's about 1,500 turns if I ran it in series, the 20 and the 22. But right now it's just 22, so it's 730 turns. The core material in this coil is 4 3/8 diameter, 2-inch in length ferrite ceramic cores, wrapped individually and then wrapped together and stuffed in there. So they're individual. There's 4 of them. That's what I had, and that's what we got. Straight up. And then this one over here has soft iron core of 6 inches, ½ inch in diameter. This is a 12 magnet rotor, all facing south, outward. And this is a 2 magnet rotor. I think it's north facing out. And that's pretty much it. And it's really simple. The trigger coil fires transistor. The transistor switches the motor. Momentum drives the whole thing.
Hey everybody, welcome to the channel. Thank you for dropping in. Drop us a like, subscribe if you like this kind of content. Let us know if you have any questions about the build he just explained.
So you can get a motor to start by itself, quote unquote, if you have like a switch in a proper position that's a contact switch, and then it's in a closed position when you turn on the power, then yeah, you're going to get a jolt that can start your motor. This one's done it several times. It doesn't do it every time. I don't know if I'm going to build that mechanism in. I don't think it's essential. I like being involved. If I have to spin it, then I got to spin it. Oh, here it is right here. And if you get it in close enough, the spaces in between will be the opposite pole. See, like this, it's all south. Out to like right here. But if you get it in close,
Well, it alternates.
yeah. And they're all facing south out. They're all out south bound.
Rotating magnetic field.
Well, no, the north field is being forced out. The rotation of the magnetic field makes it puff out farther this way and this way.
Yeah, I don't know if that's how you call it, but that's how I would envision it because it's spinning. But I think I get what you're saying. There's a push-pull effect there.
It's literally like, how do I say it? Like you put too much jelly on your sandwich and then you squish it.
Yeah, yeah.
Yeah, that little north is gonna pop out.
Nice.
Yeah, that's all that's really happening. And that's why it doesn't pop out as much, because it's like only half of the field. And I guess you get a little bit more of a bump out because it's spinning, so that's actually right. You know, both of the fields bump out because of the spin. But you can see that this one, the north, is definitely not as large as in the same direction, not as large in the same direction as the south. Because I guarantee you that it is the equivalent size. It's just being pushed in a different direction.
Hey everybody, thanks for dropping in. Welcome to the channel. I see we got 14 likes. Let's see if we can get it up to 20. We appreciate y'all.
Appreciate you. Our cat bank's up to 5 volts now. I was using a reed switch earlier today, and apparently I built this switch pretty good, because this switch is better than the reed switch. I'm pretty sure it was positioning, but as of right now, it's performing better.
Nice.
And it can work with like less energy. It's going to work more efficiently with less than a reed switch can with this coil. It's a 20 gauge 1500 turn coil. And I'm thinking that the contact switch right there is going to do a better job, or doing a better job right now. But I was even thinking of setting up another one of these transistors on this. See if we can't get it going for real. No, actually, I don't want to do that with this rotor. We can do it with a different rotor. Because you see the tape on there. I promised myself I wouldn't do anything other than homemade switch or permanent magnet motor with this rotor.
Right.
Because it's flimsy. The magnets, they're Gorilla Glue, clear Gorilla Glued in there. And they still pop out through the tape. That's how fast I had that thing going. Sick.
Thank you for the like.
Hey, thanks.
Let's see if we can get it up to 20. Welcome in, everybody.
Welcome, welcome. I'd like to reiterate my spiral design. You got your outward spiral, and then you got your inward spiral. Boom. So neat. So neat. Pulse motor art in the house. Alright. I want to try another thingamajig. Do I? I'm gonna have to, yeah, it's all right here. I can do it real fast. But I'm gonna hook up a 12 pole rotor on here. See, man, I mean, they force us to work with tools like this. You don't want to overdo it and have like a huge handle and have like this little, because I know a lot of people would do that. They just get their big handle and then defeats the purpose of it being small. And that nut is stripped, so we're just trying to get it enough. Then we put this little bearing on the top, and it spins rather well. And here it is. This is a north-south configuration. Alright, so I'm going to switch one thing over there. And I'm going to lower this a little bit because it's a little high.
Hey everybody, welcome to the channel. Thank you for dropping in.
Hello.
Drop us a like, subscribe, let us know if you have any comments, questions. No liquid nitrogen.
Alright, almost there. Yay!
Hey everybody, thanks for dropping in.
Whoa.
Let's get the likes up to 20. Let's get as many people up in here as we can. We're dropping pulse motor knowledge today. Let us know if you have any questions.
Let us know, let us know.
How's it going, 1-2? Welcome in. We are working with pulse motors today. So that's a rotor he just took off. We have the coils, power supply, switches, magnetic experiments. Thanks, Josh. Welcome in.
Hello, hello. There we go. Now, there's something not right with this one. I don't know what it is either. Oh man. So we're gonna just stick to this side. I might hook up one of these over there. See? Smooth. Almost feels like a guarantee.
Hey everybody, thanks for dropping in. I see we got 17 likes. Let's see if we can get it up to 20.
Yeah, let's do it.
Appreciate y'all.
Oh yeah, we're picking up speed with the big one. So this is a north-south arrangement, 12-pole rotor. And I want to say that it is generating more AC with this coil than it would have been if it was all north. That's what I want to say. Yes.
Yeah, it sounds robust.
But we're on, yeah, it's only 6.5 volts in, and we're at a whole amp being drawn. So it's not cheap. This rotor is not cheap. But I think it is generating more power than the other rotors.
Yeah.
Because the magnets are so much weaker than the other rotors is why I think that they're generating more because of the arrangement of north-south. And I think you can like, the way I would map out how a coil and a rotor interact would be when, say, the rotor is coming around and the magnet, boom, you freeze frame that right there, and the part where my palm is touching the mug is one iteration of how that coil is interacting with your rotor altogether. You could do it magnet by magnet, but I mean, who's going to do that? Seriously. I mean, you don't do magnet by magnet, you do one magnet and then you times it by how many magnets you have. Although there will probably be variations in every magnet. So, I mean, like if you wanted to do that, and I'll say it again, man, I mean, like, I wouldn't do that. But it could be done and your reading, final reading would be different than if you just multiply. Is it worth it though? I mean, seriously, this stuff is supposed to be fun and enjoyable, not just, you know, stress and, you know, well, why haven't we achieved it yet? Well, come on, man. I
Making
mean,
it
they all
fun.
do the same, exactly the same thing, just in a little different way. And speaking of a little different way, you see how all the coils are on the outside and the rotor is in the center?
Mm-hmm.
Well, I did a reverse rotor right here. All these coils are in the center, and then the stator would be the magnets on the outside.
Mm-hmm. That's gonna be sweet.
Yeah, it can be something cool. Now I have a toroidal. It's more of like less a half drum rotor and not a toroidal. I think a toroidal, an actual toroidal motor that's just floating there is kind of not a thing really. And I don't think it ever will be a thing. There's always going to be some part of it that you don't know is there that's keeping it together. A plasma toroidal, sure, but that doesn't weigh anything. There's components that like making a ship or something that, you know, come on now. Yeah.
Matthew says, I'm a physicist and like this work. It helps me with my thesis. Thank you so much.
Oh, you're welcome. That's amazing. Cheers. Yeah,
And he said, this is awesome. Right before that.
cool. Yeah, I like it.
Welcome to the channel, everybody. Thanks for dropping in. Let's see if we can get it up to 20 likes. Subscribe, drop us a comment if you got any questions.
The problem with the whole philosophy of riding the fence to glory is that there is no fence. People always think there's some sort of like wave that they can ride back in time or something, you know? Going, if you go 10 times the speed of light or 100 times the speed of light in anything that's made out of something physical, you're going to be reduced to cinders before you ever get there. So you can't do it that way. You can't send a ship faster than light. For what you can do is you can bring it all to you. That's how you get it done. You bring it all to you, and all you have to do then is take a step through the portal, and you're on the other side. You don't even need a ship. But I don't know. I mean, it just makes sense to me. You need to go faster than light, and if you even approach light speed with anything made out of any kind of whatever, you're going to disintegrate. It would just be obvious to me that in order for that to ever happen, it would have to happen the opposite way. You got to bring all that stuff to you.
Thanks for chilling, Mohammed. Have a good day.
Thanks, man. Appreciate it. And of course, that's my opinion. I got to declare that that's my opinion. I use logic to solve a lot of my questions. You know, I use that simple. If this can't work, and it is possible, then you have to do it a different way. That's logic. And I mean, basically, and this is, you might think this is funny or a joke or something like that, but I think Hollywood, at least in the last decade or so, has got the DL and a lot of the tech coming through that's actually going to make it. Okay? They get the DL and all that stuff before it happens. It's real. It's real. I've seen so much stuff. I mean, Back to the Future, I know it's everybody's favorite. I love the movies, too. I mean, that guitar is worth like $600,000. Oh, I think they upped the price to $1 million to whoever could bring the guitar back.
Mm.
The one that he plays at the
Yeah.
somebody stole it. Oh, man. So... And then, of course, you know, you got your Marvel movies. Man, I used to like, a buddy of mine was really into comics, and he got into drawing comics for a while when he was younger. Yeah, man, I mean, and then, you know, in order for a lot of this stuff to even be real right now, you have to believe. You have to be a believer, or it just doesn't happen. And for those of you that are not a believer, hopefully somebody, maybe even me, might show you something that'll make you one sooner than later. I mean, that's what we're all trying to do, I guess.
Yeah, Matthew, go to our YouTube homepage, and we have some contact information in the more or the about section. It's too bad that time travel is impossible because the 21st century is a cesspool.
I mean, if time travel ever happened, I would say only go forward. Take a vacation, go forward in time, because you can do whatever you want in the future because it doesn't exist yet. But don't go back in time, because if you step on a cat's tail and it runs in front of a car and that car crashes and that person dies, you may never be born. So don't do that. Somebody else may never be born. As a matter of fact, somebody else will never be born if that person was ever going to be a father or a mother. So, I mean... And is it imprinted? Is the time that you have already experienced imprinted somehow? Therefore, you can go back and it would be like rewinding a tape because it's imprinted. Or is it just This is something totally different. I would say it's more or less not like rewinding a videotape. It's not like you go backwards in time, people start walking backwards. That's not what happens. You know what I'm saying? It's like, I don't know. I really don't know. As a matter of fact, the reason I think I don't know is because it doesn't happen. But I don't know. I really don't.
All right, man. I got about 5-10 more minutes.
All right. I'm good, man. We can just wrap it up.
All right.
All right. So, thank you very much, ladies and gentlemen. I really appreciate you all coming out and hanging with us tonight. We got our cat bank halfway charged up, just chilling here, and you know, I do a lot of stuff with the pulse motors. I try to stay away from fantastic stuff. Try to keep it scientific. I've seen, you know, a lot of, you know, more elaborate, and just beautiful designs of pulse motors. Check out 0-point motors. You know, there's a lot of stuff you guys check out. But yeah, this from Papa Bale. Keep it simple. Have a great day. Bye now.